So while a universal quantifier says that our propositional function is true for every value of the variable in the domain under consideration, the existential quantifier is kind of the flip side of that. It says there is at least one value that makes our propositional function true. So the definition of an existential quantifier is as follows. So with this, there exists x such that p of x, we mean the proposition there is at least one value of x in the domain of consideration that makes your propositional function right here true. So again, to be able to read this thing, there's a bunch of different ways to say it. So a few examples if you want to go and take a look in Rosen for a few more, but it says, you could read this backwards E as there exists, or there exists some x such that p of x, or for some, or for at least one, etc., etc., etc. And by convention, the way that you would read this bunch of symbols right here, we usually stick verbally a little such that inside there. So you could read this bunch of symbols, there exists an x such that p of x. And so you might see me abbreviate a few times s dot t, and I'm going to use that abbreviation for such that. So let's go ahead and look at a few examples of this existential quantifier right here. And in fact, in the past couple of videos, I've been saying all real numbers and writing out all real numbers, and that's going to get very boring to have to say that a lot. So I'm going to use a mathematical abbreviation right here. This little double struck R right here, this means all real numbers. So whenever you see that symbol right there, that means all real numbers. It's just shorthand. So here's my propositional function right here. I have my predicate, x squared is greater than x. Let's go ahead and consider the existential quantifier. There exists a real number such that x squared is greater than x. Is that thing true or is that thing false? This right here is a proposition, so it has a truth value. Let's try and figure out if it's true or false. So, well, by definition, it just has to be true for at least one value of x right here. So if I were to consider some value of x, such like, I don't know, how about x equals 4? If we consider x equals 4, then p of 4 is going to be our statement 4 squared is greater than 4. And last I checked, yes indeed, (16) is greater than 4. So this existential quantifier right here is true. There exists at least one value in its domain that makes this propositional function right here true. So this thing is logically equivalent to true. That is a true statement. However, in contrast, if we were to take the same propositional function right here with the same domain and consider if the universal quantifier, this particular proposition is true or not. How would these two differ? Well, this one claimed for at least one value, and we found one value, such that x squared is greater than x. This right here is making the claim that for all real numbers, x squared is greater than x. Well, this thing right here, this is going to be false. And I can prove that it's false by giving a counterexample. Let x equal 1/2. And if we let x equals 1/2, then p of 1/2 is the statement 1/2 squared is greater than 1/2. That right there is saying 1/4 is greater than 1/2, which is definitely false. So there we go. I have found a counterexample. The universal quantifier of this particular propositional function right here is false, but it's true for at least one value, so the existential quantifier is true. There exists a real number, x, such that x squared is greater than x. So that is our existential quantifier. There's some value that makes this propositional function here true.